All right, I'm going to go ahead and get started here. I was going to do a quick meeting for you guys to kind of go over a few concepts that you're likely to run into with the test coming up early part of next week. So the bottom of the last lesson goes through kind of a general list of all the topics you're going to need to be familiar with for the test, and that's going to be a really good jumping off point for you. Remember, anytime that you go through and are looking at, okay, these are the things I need to know for a given test or a given assessment, you want to make really sure that not only can you do like the very kind of base level information regurgitation that they're looking for, but you want to be able to take it a little step further and go, okay, can I give examples of this? Can I explain a situation where this would not happen? You want to try to take it from every angle that you possibly can to make sure that you've got your bases covered by this general topic. I've always told students a good rule of thumb is to use those 5 question words when you're dealing with any type of goal or objective that you're supposed to know for an assessment. You know, what does it say? You know, why does it work that way? When does this occur or not occur? If the who is applicable, you know, who developed the idea? And then, you know, maybe the how. If it's, you know, something like writing formulas or coming up with writing an equation or doing a math problem, you want to make sure that you know how to do how. So not all 5 question words will apply in every situation, but they're a really good place to start to make sure that you're getting every angle of that particular objective. Excuse me. So I want to kind of go over a couple of things real quickly that I think are going to be a little bit confusing or problematic. In general, so far, it seems like people are understanding the idea of homogeneous and heterogeneous pretty well. Make sure that you have a good understanding of what those prefixes mean. What does that mean for mixtures, and what does that mean for other substances? A lot of people think that homo and heterogeneous only apply to mixtures. In fact, all of matter can be kind of grouped into those general categories. For example, you do have homogeneous mixtures, things like salt water. Or sugar water. But you can also have homogeneous substances. Remember, substances are things like elements and compounds. They're not mixed together, but because they're the same all the way through, they are considered to be homogeneous. So for example, just water, which is a compound, that's homogeneous. Oxygen would be homogeneous. Iron would be homogeneous. And so make sure that you're when you think about those terms, you're also keeping in mind things that are not necessarily mixtures, but could also be considered to be homogeneous as a result. Heterogeneous really only applies to mixtures because you have to have the different parts, the different components, not mixed evenly. So a really good, a very common example of that is things like salad dressing. You know, you can see all the individual parts, it settles when it stands, that type of thing. But air is also heterogeneous. So, you know, well, no, that's not true. Air is a mixture, but it's homogeneous. Sorry, I misspoke. But seawater is heterogeneous. The saltwater part of seawater, that's homogeneous. But then you have all those other components, the microorganisms, the plant and animal life, all of that makes it heterogeneous. So make sure that you're looking at the whole, not just the part. And if you're not sure, if they give you something like salt water where you could kind of go, okay, are we talking about the water part or are we talking about the entire thing? You want to ask. Make sure that you ask because that way we're all answering the same question. Or if you're not 100% sure and you don't have the opportunity to ask, make sure in your answer that you explain. You know, like for example, I would say that the saltwater part is homogeneous, but these other factors make seawater heterogeneous. By explaining your answer or being prepared to explain your answer if you want to argue for points, then you're going to be in a better position to be able to make sure that you communicate fully what you know. You also want to make sure that you have a solid understanding of what are solutes and what are solvents. That ties back in with mixtures. Remember, solvent is the larger portion. It is the thing the solute dissolves in. In most mixtures, solvents are liquids of some kind, but not all. And so what you're looking at is you have to think in terms of, okay, what is the base in which I am dissolving or mixing the solute into? That base is the solvent. All right, so I don't want to go and say, okay, well, it's the liquid part, because that's not always true. Like we said, air is a mixture, and so nitrogen is the solvent because it is the primary ingredient, and then everything else is, I guess, what you would call dissolved in it. It's mixed together with it. But solvent and solute are usually only used in terms of liquid mixtures. So most of the time you'll see it referred to as the liquid that you're dissolving into. You need to be very familiar with how to calculate density. Make sure that you're comfortable with that. And make sure that you understand that sometimes they're going to trip you up, or at least try to trip you up, by having things that are, they want you to calculate density in grams per cubic centimeter, but they gave you a mass in kilograms. Make sure you watch those labels, because if you need to do that conversion, you need to do it before you calculate density, because it changes. You would go about solving it differently if you'd already calculated density, and it gets really complicated. So it's much easier just to change it before you calculate density. You also want to make sure that you're very familiar with state changes, not just the terms involved, although there's several terms involved with the different state changes: evaporation, condensation, transpiration, boiling and freezing, etc. You want to also understand what's happening with the energy as we move from things like solids all the way up through liquids. What's happening with the energy level there? Okay, it's discussed in your lesson, but make sure you go back and review that idea of, as we go from energy, or from state to state to state, the energy is changing. Also, remember that as you go through a state change, as you are melting, for example, the energy continues to go in. All right, because if you have a pot of ice on your stove, you have to keep the heat turned on or it won't melt. But as it's melting, the temperature won't change. So while you're still putting energy in, every time you go into a state change, it doesn't change the temperature. And that's because the energy can do one of two things. It can either change the temperature, it can make it hotter or cooler, or it can change the state. But it can't do both at the same time. All right? It can't divide itself that way. So energy can only be used for one thing at a time. And that's a pretty consistent rule throughout most of chemistry and physics. If energy is doing something, that is the thing it is doing. It can't be doing other things as well. All right, so if the energy is being used to move a mass across the floor, it cannot also be used to heat a room. All right, so energy can do one thing at a time. All right, one of the things that you'll probably find to be most challenging is going through the significant figures rules. And that's very individual, what people are going to struggle with as far as how to read and interpret and understand significant digits or significant figures. It's the same thing, just different terminology. You want to make sure that you understand the rules, that you can determine how many significant figures are in various numbers. Like I've said in previous classes, the numbers 1 through 9 are not usually the problem. The problem is what to do with those zeros. If you find that you are struggling or you don't understand why we need to do significant figures, which is also equally as important, if you find that to be the case, let me know, because I have a PowerPoint that goes through that with you. I'm not going to go through it with you right now because I don't want to take the time to, go through and teach the entire lesson. But if you find that you are struggling with that concept, let me know and I can send you a PowerPoint about it that I think you will find to be really, really helpful. Because it's a very common area for people to struggle with, especially here in chemistry, where it's the first time you run into the idea that not every number is going to be, or not every digit in a number would be significant. Finally, you want to make sure that you review your CONPTT grid. You look at your scientific statements, decide, okay, is this idea scientific or not? Using that CONPTT grid, you understand, that stuff from last week that we talked about. And then you also want to make sure that we're going to touch a little bit on physical and chemical changes. We'll get into it much more in the next unit. We're really going to dig into it in the next unit. But you want to be, you want to be comfortable with this idea of the differences between physical and chemical changes. Remember, a physical change is a change to the physical state or organization of the object. It does not change it fundamentally on a chemical level. So I usually say you can tell you've got a physical change because it's changing something about it that you can detect with your five senses. That it is reversible. Anytime you have a physical change, you can reverse it and get back what you started with. And you have the same thing at the end that you had at the beginning. So for example, if I melt an ice cube, I can take that water, put it back into the mold, refreeze it, and get an ice cube back to it. It's reversible. And liquid water is still the same thing chemically as frozen water. There was no change there. Chemical changes, on the other hand, change the chemical composition of what you're working on. And so they are not reversible by any kind of normal means. And then they also tend to produce a different product than what you had initially. So for example, if I have a pile of leaves and I burn those, burning is a chemical change. When we are done burning, the leaves are not the same. They're not the same compound as what they were at the beginning, and we can't get them back. I can't unburn something. Even if I were to gather all of the gases that escaped in the smoke and put it all back together into a container, I cannot undo what I have done. Those are a good litmus test for whether something is a chemical or a physical change. Can I reverse it? And do I have the same thing at the end as what I had at the beginning? If you can say yes to those questions, then what you have is physical. If you say no to those questions, what you have is chemical. All right? So for example, and there can be, within the same process, there can be physical and chemical changes. So for example, making a cake. On the surface of it seems like it's chemical, and it is when you bake it. But as you're mixing the different ingredients together, there isn't really a chemical change that's happening there until you start to add the eggs and you start to see those bubbles form. Okay? That's where you begin to have the chemical change. So you have to be careful where in the process you're talking about it. But usually, Occam's razor, the most obvious answer is usually going to be the right one. And so, if somebody gives you the option of saying, is baking a cake chemical or physical, it's chemical, because they're talking about the process of baking. And you can't take your cake at the end and break it back down into sugar and flour and oil. So keep those things in mind as you're moving forward and you're getting ready for studying for the test. Like I said, we're going to address chemical and physical changes in a lot more detail next unit. We're going to talk about the signs of a chemical change. How do you know if a chemical change has occurred? And all of those good things. And how does that then affect our understanding of what's happening to the elements that we're working with? If you have questions about significant digits, please let me know. Send me an email. I can email you that PowerPoint that you're going to need. Significant digits are going to affect all of the problems that we're going to work on going forward. So you really want to make sure that you have a good, solid understanding of it in this unit so that it doesn't affect you down the line. So hopefully this was helpful to you. Went over just a few concepts with you real quickly. Remember to go back over those objectives at the end of the very first lesson. That's going to give you a really good sense of what do I need to study, where do I need to spend my time. Take the time, write them down, see if you can use those 5 question words to answer them. Anything you have to look up, that sends the signal. This is where I need to spend my time studying. The things you already know how to do are not the things you want to spend your time on. All right? Human nature says I want to study the easiest things possible because we're all lazy, and I do it myself. But bottom line is you need to spend the time on stuff you don't know how to do, not the stuff you do. So make sure you hold yourself accountable as you're going through those list of things to study, the need to knows, and that you're spending your time in the most productive place possible. All right, everybody have a great day, and thank you very much for watching.